Question number 5. If sin A plus cos A is equal to root 2, find sin A into cos A. Start with the given equation sin A plus cos A is equal to root 2 and square both sides. Eliminate the square root and introduce a term involving sin A and cos A. Expand the left side. So we get sin square A plus cos square A plus 2 sin A into cos A is equal to 2. Use the fundamental trigonometric identity sin square A plus cos square A is equal to 1 to simplify the equation. 1 plus 2 sin A into cos A is equal to 2. Isolate the term 2 sin A into cos A and then solve for sin A into cos A. Move 1 to the other side, then it becomes 2 sin A into cos A is equal to 2 minus 1. This implies 2 sin A into cos A is equal to 1. Now isolate sin A into cos A. Divide both sides by 2 so that sin A into cos A is equal to 1 by 2. The value of sin A into cos A is equal to 1 by 2. Question number 6. So that tan theta plus cot theta is equal to sec theta into cosec theta. Begin with the left hand side of the equation and rewrite tan theta as a sin theta upon cos theta and cot theta as cos theta upon sin theta. Find a common denominator which is cos theta into sin theta and numerator becomes sin square theta plus cos square theta. Trigonometric identity sin square theta plus cos square theta is equal to 1 to simplify the numerator. RHS sec theta into cosec theta. Apply the reciprocal identities so that sec theta is equal to 1 upon cos theta and cosec theta becomes 1 upon sin theta. Result is equal to the left hand side of the equation. Therefore, LHS is equal to RHS, hence proved. Question number 7. Prove sin theta upon 1 minus cos theta plus sin theta upon 1 plus cos theta is equal to 2 cosec theta. Add the two fractions. Write the common denominator 1 minus cos theta into 1 plus cos theta. Numerator becomes sin theta into 1 plus cos theta plus sin theta into 1 minus cos theta. Sin theta as a common factor. Open bracket 1 plus cos theta plus 1 minus cos theta bracket close upon 1 whole square minus cos theta whole square. The denominator is a difference of squares. Plus cos theta minus cos theta cancels, leaving 2 sin theta upon 1 minus cos square theta. We know that 1 minus cos square theta is equal to sin square theta. Sin theta cancel, leaving 2 upon sin theta. Using the reciprocal identity, cosec theta is equal to 1 upon sin theta. So we get 2 cosec theta. This is equal to the right hand side of original equation, hence proved.